Welcome, and thank you for joining today's conference, Rubber Meets the Road. Before we begin, please ensure that you have opened the chat panel by using the associated icon that's located at the bottom of your screen. If you require any technical assistance, please send a chat to the event producer. All audio lines have been muted for the duration of this call. To submit a written question, select All Panelists from the drop-down menu that's in the chat panel. Enter your question in the message box that's provided and then send. With that, I'll turn the call over to Liz Fernandez. Please go ahead.
All right. Good morning, everyone. I'm Liz Fernandez with Professional People Training, and I would also like to welcome you to today's Rubber Meets the Road webinar. Our speaker today is Dr. Brad Christensen. Dr. Christensen is a Wyoming native and a Colorado State University graduate who joined APHIS Veterinary Services in 2015 after 12 years of private practice in Nevada. He has been working as a veterinary epi officer for the state of Kansas since 2016 and is also a member of the VS Indigo Incident Management Team. And with that, I'm going to turn the webinar over to Dr. Christensen.
Thank you, Liz. Can you hear me okay?
We can hear you. Yeah.
All right. I'm going to turn my camera on. I hope my good looks and sarcastic humor don't distract you from the content of the presentation today. I'm here to talk to you about my Grassroots project from 2020 called the Kansas Epizootic Hemorrhagic Disease Prevalence Project. I want to, before I move forward, make sure I recognize Dr. Robert Keener. He's an assistant professor of animal science at Fort Hays State University. We did this project in partnership, and really the genesis for this project started with some thoughts and ideas he had in conversations that started in 2018 and 2019. Sorry, it's going slow. There we go. Outline of what I'm going to talk about today, purpose of the project, what we found, move through to talk about some of the results, discuss what we found and some things we can do moving forward. The general purpose of this project was really to just determine if and what level of prevalence or exposure to epizootic hemorrhagic disease, or EHD, we have in cattle in west central Kansas. This is where Dr. Keener is located, but it's an area there's been a lack of surveillance in. We know EHD exists in deer, both wild and domestic in Kansas. It's been pretty well documented across the state, but we don't have much data to support the reports of EHD in cattle, even though we suspect it's out there. Our main goals were to collect test data that could help determine if there is a presence of or there was previous exposure to EHD in livestock in western Kansas, and also to detect the presence of culicoides, the main vector for EHD. This second goal, vector surveillance, was really not part of our initial project, but early on in research for this project, we started collaborating with ARS, our Ag Research Service in Manhattan, and there was a mutual interest in doing some insect trapping out in this area because there hadn't been much there before, so it was a nice adjunct to our project. Let's talk a little bit about the basics of EHD. I think a lot of you are probably fairly familiar with this disease. It's an orbovirus, multiple serotypes. It's very closely related to the blue tongue virus, so you'll often see them lumped together in different literature sources, often even tested together because they're so closely related. Clinical signs, it varies by species. Really the main clinical symptoms we see are in our cervids, primarily white-tailed deer, but you can see it in some other species. And even there, it varies from a peracute to a chronic form, multiple different types of presentations, lethargy, respiratory distress, diarrhea, dehydration, and oftentimes death in deer. But it can be subclinical as well. We don't see it frequently cause clinical disease in cattle. It will, but In Asia, they do see what they call Epizootic disease in some Asian cattle. So this is a worldwide disease issue. Primary species we worry about, really cervids is the main focus, especially white-tailed deer, but we can see it in other ruminants as well, cattle, bison, yaks, sheep, bighorn sheep, and others. Morbidity and mortality, again, it varies by species, but within deer, white-tailed deer, you can have up to 90% morbidity and mortality. Recent U.S. cattle outbreaks, we've seen reported morbidity rates of 1 to 19% and overall mortality of 2%. In 2012, there was a large outbreak across the Midwest involving 15 states, and our own Dr. Gary Stevens from Nebraska co-authored a paper about that. They found that within herd morbidity of EHD in cattle and bison was about 7%, whereas in deer, captive white-tailed deer was about 46%, and the deer also had about a 42% mortality rate. So it's definitely a difference between presentation in deer and cattle. Transmission, this is a vector-transmitted disease, biological vector, the culicoides, or biting midge. Distribution of the disease is really the temperate regions around the world between the 35 south and 49 north latitudes where the biting midge is most likely to be found with those climate characteristics. This quote that I put at the bottom of this slide, I pulled from Iowa State University Centers for Food Safety and Public Health because I feel like it sums up a lot of the reasoning, a background of why we did this project. Seroprevalence rates among cattle in endemic regions can vary from 1 to greater than 60% depending on the region and year. Because few or no clinical cases are usually reported, these antibodies are thought to result from subclinical infections, and this is in reference to cattle. However, some cases might be missed due to a lack of awareness and diagnostic testing. So that it kind of goes back to our thought that it's out there, but are we just missing it? Are we not looking for it? And that was really what started this project. A few pictures. We're always obligated to show some pictures in these presentations. Upper left, this is a picture provided by Dr. Luann Schneider, one of our VMOs here in Kansas. This was from an actual FAD investigation that was done last year on a 1-year-old Holstein steer. This steer presented with depression, diarrhea, fever, drooling, edema of the lower lip, which ended up being EHD positive on testing. It came from an area where we'd also had positive vesicular stomatitis virus detected in horses nearby. I'll come back to this case at the end to discuss it a little bit more. The deer pictures you see were provided by Shane Hessing from our Kansas Department of Wildlife, Parks, and Tourism. Pretty typical presentations for hemorrhagic disease in deer. They often lump hemorrhagic disease together in blue tongue and EHD because they have similar presentations. But the deer on the bottom, you can see open mouth breathing, respiratory distress, obviously sick if you can get this close to them to take a picture. On the right, another whitetail sitting in the water, obviously febrile, trying to seek to cool down. It's hard to see in this picture, but there's some bloody, frothy foam coming from the nose. So it's very bad disease in white-tailed deer. It causes our producers a lot of headaches, and our wildlife folks here in Kansas frequently find these cases. Methods for our project. Really 4 main facets of how we did this project, and I apologize for all the acronyms. I just did not have enough room on these slides. But the first part of the project started with a review of historical data. Wildlife information we got from SCWDS, our Southeast Cooperative Wildlife Disease Survey, and Kansas Department of Wildlife, Parks, and Tourism provided us some historical data to review. part of our cattle. We looked up information on our Strand website, which is our ability to access tests that go through our National Veterinary Services Laboratory Network. Also looked through some of our EMRs, our Emergency Management Response. Sorry, I can't remember all these acronyms either, but our Emergency Response Database, and then our non-laboratory here at K-State also provided data. And I'll present those in following slides. The bulk of our project was sample collection and testing. Our focus was on cattle, and we chose to test adult cattle, cull cattle primarily, coming through livestock markets in central western Kansas for a few reasons. One, there's a higher chance of previous exposure in our adult cattle. There was a study done or published in the American Journal of Veterinary Research in 2007 from a similar sero survey done in Indiana and Illinois in the mid-2000s, where they found that cattle were 2.35 times as likely as adult cattle were 2.35 times as likely as juveniles to be seropositive for blue tongue, which again is similar to our EHD, but we're looking for animals with a higher chance of previous exposure. Also, it allowed us to collect cattle samples from a larger geographic distribution, so people coming from multiple areas bringing cattle to a central location. It was a convenient sampling. These cattle were going to be coming through a chute anyway, being processed. The market was very gracious in allowing Dr. Keener to come and pull blood samples. In addition to that, we had record availability where we could determine the county of origin for these cows based on seller records, and we could also evaluate official ID. We did not collect any information on owner name or addresses or contact information. We were just concerned about the source of the cattle. All the sampling, blood sampling, was done between June and September to coincide with vector season, our biting midge season. The next phase was the actual testing, which was all done at Kansas State University Veterinary Diagnostic Laboratory, a combination of PCR and ELISA testing. And finally, the fourth facet was our insect trapping, which occurred at two different locations in Ellis and Rush counties. Talk a little bit more about that. As I mentioned earlier, this was done in collaboration with our USDA ARS partners in Manhattan, Kansas. There had not been any previous insect surveillance done in this part of Kansas. It was a gap that they mentioned that they were interested in filling for surveillance, so it worked well for us because it happened to be right in the location that we were going to be doing all of our projects. The primary species they were interested in were black flies, sand flies, and biting midges, mostly in relation to vesicular stomatitis virus, but it fit in nicely with our EHD that we were looking for because of the biting midge. The testing occurred overnight from dusk to dawn. We did it once weekly as allowed or could as weather allowed. And the locations where these traps were set up were based on a few criteria. One, we needed to have them in an area where there were cattle to attract these insects. Tried to reduce in an area where there was reduced wind exposure. Anybody familiar with Kansas knows there's no place in Kansas with zero wind exposure, but we tried to limit it as much as possible. Needed to be close to an open water source, so these were nearby ponds, again, to encourage vector activity in that area. And then also needed to be long ways from ambient light sources, so nowhere near any kind of towns or large buildings with exterior lighting. In that picture, you can see the elusive Dr. Keener, rarely photographed in the wild, placing a trap, actually just this last week. These were hooked to a small battery. They would run overnight. Insects would come into this trap. They would be collected down in that container at the bottom of the trap, ethylene glycol. store them overnight, or actually for longer periods of time, depending on how often we could transport. This is a map of Culicoides sonorensis range that was provided by Angela James, at our entomologist at our SIA group in Fort Collins. The point of this slide really is just to show that this vector is pretty widespread across the United States, and we recognize it's definitely in Kansas, but within state distribution is a little less well known, at least here in Kansas. As far as climate goes in Kansas, Culicoides requires some degree of water as part of their life cycle, but we also know that some species require being completely submerged, and some can even survive or develop even as the amount of moisture that's found in manure. But Kansas is a state where there's a pretty wide variation in precipitation, and it's very dry out in western Kansas, 18 inches annual precipitation, all the way to southeast Kansas, where we can see as much as 45 inches. So there is less water, less precipitation in the western half of Kansas where we were doing our project as compared to eastern Kansas. Again, another background slide on Kansas. And we have a lot of cattle, we have a lot of deer in this state. Two species that are susceptible to EHD. We have number 3 overall for cattle and feeder cattle. We have over 470 licensed feedlots, probably the majority of which were in western and southwestern Kansas. We also have nearly 80 captive cervid operations. There's a lot of susceptible species for EHD in our state. I'm going to start into the section talking about some of the historical analysis of the data we came up with. In wildlife, lots of good data dating all the way back to 1980. Our state wildlife partners have worked with the SCWDIS, the Georgia Southeast Cooperative Wildlife Disease Survey Group, for many, many years to try to map and track hemorrhagic disease in white-tailed deer. They have found laboratory detections in multiple counties across the state, but in a following slide and map, I'll show you the disease that we see clinically seems to be more predominant in the eastern half of the state. As far as cattle goes, there was very little data on EHD infections in cattle in Kansas. 2012, the outbreak that Dr. Stevens had wrote about involved many, many states, including Kansas, but as many cases that were detected that year, we only actually found one in Kansas, and it was in northeast Kansas. Reviewing more data between 2015 and 2019, I could only find one EHD positive PCR in cattle, and that was in 2019. So not much out there. We just haven't detected it very often in cattle. This is our wild cervid or wildlife EHD map. Actually, it's a hemorrhagic disease map, so this includes both EHD and blue tongue from 1980 to 2012. So it's not completely current, but it gives a good picture of what we've found in the past. All the yellow, orange shaded or colored counties represent a county where clinical hemorrhagic disease was found in deer in that time frame. Any of the patterned counties, dots or hash marks, represent those that had laboratory diagnosis. You can see a pretty distinct difference between western and eastern Kansas here. A lot of clinical disease is found in eastern Kansas. I put a snippet up in the right-hand part of this slide. It was from the Journal of Wildlife Disease in 2004 that discussed this difference in variation, and that they proposed that it may be related to the different subspecies of deer in Kansas. We happen to have two groups or two subspecies of whitetails in Kansas, one that inhabits the eastern half and one that inhabits the western half. And the thought is there may be a difference in virulence between these two subspecies because both groups they've found antibodies in, but they see more disease in the eastern subspecies. Just real quick, I don't know if you can see my pointer, but I just want to highlight this area of west central Kansas that there's just not much data in that time frame. Another map, we collected further information from 2015 to 2019 for both wild and domestic deer as well as cattle. These are all laboratory confirmed. So all the yellow counties represent laboratory confirmed either wild or domestic deer detections between 2015 and 2019. You can see our single cattle detections right there in the center in the orange crosshatch area in Saline County. Again, I could kind of point out this area of west central Kansas, not a lot of activity or detection in that area in that time frame. Well, I'm going through these a lot faster than I expected, but just a quick summary of our testing. We did ELISA testing, serology to look for previous exposure to EHD. I could not find a good definitive resource that showed how long EHD titers last in cattle, but we can conject that it's probably at least a year or two, maybe longer, for exposure or since exposure. We sampled, I should say Dr. Keener sampled 157 head in a couple different visits to the market in August. And we got, this represented cattle from 10 different counties. In separate pools of cattle, Dr. Keener pulled blood on 195 head in groups in June and September, so roughly early and late summer, kind of early and mid to late vector season. Cattle from these samples represented 16 counties of origin. We would like to have had ELISA and PCR on all of them, but we had to stretch and adjust to fit our funding. The next few slides are tables of results. A little bit busy. This slide breaks down the serology results based on official ID state of origin. We have cattle with ID tags from five different states, most of which were from Kansas. There's no way to know when these cattle may have got a tag or moved into Kansas. But the shocking thing for us was 99% of the serology samples we took were positive for EHD, something that we never expected. In addition, 14% were blue tongue positive, and 14% were also dual positive for both. This is the same information that's just broken down by county. We'll see on a map in coming slides. But 10 different counties, samples weren't evenly distributed across all counties, but again, 99%, nearly a full, our entire sampling was positive for EHD on serology and 14 for blue tongue. The 2007 paper that I referenced earlier from the American Journal of Veterinary Research that discussed an Indiana and Illinois seroprevalence study done in the mid-2000s, they found about an 11.8% EHD positivity rate, again, which is significantly lower than what we found. That ranged from anywhere from 5.2 to 15.3% rate over the 3-year span that they did this project. And also for their blue tongue, they found about a 1.5%, which again is a lot lower than what we found, but their range was anywhere from 0 to 11%, depending on the location. So that 11% is fairly close to what we found here in Kansas. This is our PCR results, just broken down by county alone. 16 different counties, We didn't find much, which is not real surprising because we're detecting really ongoing or recent exposure to EHD and blue tongue. Did find one resource that said that this virus could potentially, or at least antigen, could potentially be detected on PCR up to several months after infection, even if no viable virus remains in the body. So potentially this could, reflect a little bit larger time frame than just in the weeks around when we took this test. But overall, we had a 2% positivity rate on PCR for EHD. I will note that 2 of these 3 positive cases were actually FAD investigations that were done outside of our project, but included because we felt that they were definitely pertinent to what we were doing. Also, there were 11 blue tongue positives, so about a 2 and 6% positivity rate on PCR. Here's the map. This is building off of one that I showed in previous slides. The yellow counties are historical, 2015 to 2019 deer laboratory confirmed infections. We had that large gap in west central Kansas where we hadn't seen much. The orange county right in the center is that lone single cattle PCR positive that I found on review of the data. The brown counties on this map, these 10 counties represent the seropositive counties where we found EHD in our cull cattle. The brown cross-hatched 3 counties represent the 3 PCR positive counties, of which include that Holstein FAD investigation we had a picture on in earlier slides. I did not add blue tongue to this map just to try to keep it simple, but basically we found a high level or high exposure rate based on serology in that west central Kansas where there wasn't a lot of previous data. I'll talk a little bit now about the insect trapping that was done over the summer. Started in June and carried on through November. Basically our typical vector season for Chelocoides. You may not be able to read all the numbers, and that's not that important for the graphs on the left. Those represent 2 different locations where the traps were located. You can see on the upper right, the map insert, the stars represent where these traps were located, pretty much right in the center of where all of our cattle were coming from. What we see is a solid line that represents the biting midge detections, and then black dashed and dotted line are black flies. This graph was created for us by our ARS partners after they did their insect identification. What we basically see here are similar peaks in Chelocoides activity or detections in June, and with a few smaller peaks throughout the rest of the summer. Black fly detections were a little different. One midsummer was the peak, whereas the other we had early summer and into the fall for that detection, but our Chelocoides charts matched up fairly closely. The picture on the right, the lower right, is where one of these traps was located. It may be difficult to see, but there's a pond nearby this trap. It sits in a little bit of a drainage or a draw that's protected from the wind a little bit better, and this is in a pasture where cattle were kept. In the very far background is a city, but it's a long ways from an ambient light source. I did mention this in earlier slides, but I wanted to talk real briefly about a different outbreak that we had during the summer of 2020 here in Kansas, because there are some similarities and information that we can pull that relate to our project. In 2020, we had a very large outbreak of vesicular stomatitis virus in the state of Kansas, primarily in southeast and eastern Kansas, that started in the summer in June and carried on into the fall. A virus that we weren't really familiar with because we hadn't detected it in Kansas prior to 1919, and even then it was just one case at the end of the year. So something new, but it was a massive outbreak, well over 200 investigations for us, multiple positive premises, some of which did have some cattle detections. They share a common vector. The Vesicular stomatitis can also be spread by the culicoides. So we had some cross interest, even though these were in different geographic locations from where we were doing our project. This is a time-lapse map that our friends at CEO were gracious enough to make for us. Before I start, what you're going to see is our detections on a base layer of river drainages, just to point out the fact that, just so we can show how closely these infections popped up along waterways and water sources, probably heavily vector-driven. Red will reflect positive laboratory diagnosis. The light colors will be suspect cases. This starts in June. Really, the beginning was concentrated in south central Kansas in a few different counties, but as we moved into July, you can see it began to spread into eastern and southeastern Kansas, and our neighboring states can attest that it got into Missouri and Oklahoma and Arkansas, kept them pretty busy this summer too. But you can see they cluster along waterways. Even those that aren't directly on a waterway were oftentimes near an open water source like a pond or reservoir. But this, as I mentioned, is in eastern Kansas, so it's a little different geography from where we were doing our EHD study, but a very similar time frame. I can't make direct correlations between the VSV outbreak and what we were doing with our insect trapping, but out of curiosity, I overlaid our insect graph and our VSV epicurve. We'd happen to see that there's a peak in culicoides activity in June, which seems to coincide with the beginning of our peak of VSV cases that we saw. Again, you can't say that they're directly related, but potentially there might have been more vector activity across the state in 2020. We just don't know because there was no previous testing, insect trapping in that area to compare against. This was the second location, basically the same thing. So again, it just stimulates some thought processes for us. Again, we can't make any conclusions based on that, but I just thought it was interesting. And finally, I'll go talk about some of the things we learned, what we got out of this study. Probably the main thing was that we got out of this study that there was a much higher rate of EHD positive ELISA than we expected. Again, there could be some other factors involved, but our conclusion is that there was probably a lot more exposure to the EHD virus in cattle in this area over time than we had anticipated. Again, it's 99% versus almost 12% what they found in Illinois and Indiana. I can't explain that difference. We may just have a stronger vector activity in this part of the country, a little further to the south, but definitely a large difference. And they also tested over 3 years where we tested one summer. As far as blue tongue, we did find some similar rates to what Indiana and Illinois had found. They were 1.5% positivity rate on average versus our 14, but as I mentioned earlier, they had a range of up to 11% positive. So both of these viruses, that we know they're out there. Even though we're not seeing them a lot in cattle, this testing is showing us that it is there and it is present. There were definitely some limitations and obstacles we had to overcome due to COVID primarily. When we envisioned this project, Dr. Keener had planned to involve some of his students at Fort Hays State University to get them involved, help them to become familiar with a scientific project and give them some activities out in the field. But due to COVID, they all had to leave, return home, do school over online methods, so we didn't have those students that we initially anticipated. So Dr. Keener pretty much did all of the blood sampling and insect trapping himself for the duration of the summer. Travel restrictions also ended up becoming an issue. I did not pick up and transfer samples from our locations to ARS as frequently as I'd like to have. That allowed for some of these samples to degrade to a point where they could identify a biting midge, but they could not break it down by species any further than that. So we got numbers, but we didn't really get a good feel for what species we were seeing. Another maybe not a problem, but a surprise was the fact that there wasn't a lot of historical data for our domestic cervids as well as our cattle. Again, not terribly surprising. I thought we'd maybe see some more. We had a lot of good historical data for our wildlife, but much of a good portion of the classifications for wildlife are based off of clinical suspects and may not always be tested. They're pretty good at being able to say, yes, this is a hemorrhagic disease, probably either EHD or blue tongue, but not all cases were technically tested. And going back to the VSV discussion, we cannot make direct correlations between that outbreak and EHD necessarily, but they do have a shared vector. I still think there probably was some sort of relation between what we were seeing in western Kansas and maybe what was happening in eastern Kansas. One maybe fortunate side effect of this outbreak, it was so large scale for us that the Kansas Department of Agriculture did a great deal of outreach to our accredited veterinarians in the state and our producers. So our overall passive surveillance was probably as good as it's been for cattle in a very long time, maybe more likely to detect things like EHD, blue tongue, and we still only found 2 cases on FAD investigation. I think that just shows how often this disease is subclinical and hard to detect. And getting close here to the end. Moving forward, we'd like to continue insect trapping with ARS. There's really no cost to us to do this, and we feel like it's good information that can be shared between our groups. We will try to be a little more efficient this summer. I'll be picking up samples and delivering them more frequently in hopes that the samples can be speciated and to give us a little bit more information than what we had last year, but also maybe give some more information on trends over time for western Kansas. I plan to meet with the Kansas Deer and Elk Association at their summer meetings this year. EHD, blue tongue, these are diseases that they hear about all the time. EHD is a particular interest and a heartache for our deer producers, so hopefully be able to use this as an opportunity to do some collaboration and outreach with them. And finally, just a couple minutes on this. I think for our own purposes, at least mine, I need to, blue tongue and EHD probably for our case needs to be considered more frequently. We need to have increased awareness for this with our future FAD investigations. To give a little, I'm going to read this quote real quick that we showed earlier. Because few or no clinical cases are usually reported, antibodies are thought to result from subclinical infections, which I think what we found supports that. But however, some cases might be missed due to lack of awareness and diagnostic testing. This picture of this Holstein, going back to this case, a little background, this animal came from a herd that 1 week previous to being diagnosed as EHD positive, had another initial FAD investigation where multiple animals were showing similar symptoms, some of which had oral lesions, oral ulcerations on the dental pad. We had performed foot and mouth testing and vesicular stomatitis testing, both of which came back negative. And part of that was a concern because we had positive VSV cases in horses nearby recently, so it may have steered us towards that concern in this particular animal. But the second round, our VMO added on EHD and blue tongue testing, and it came back positive. I looked back, this real cursory review of our FAD testing since 2009 here in Kansas, not counting swine investigations. We've had over 70 FAD investigations where we did FMD testing, but only about half of them included EHD and blue tongue. So, sometimes we're doing it, sometimes we aren't. It's not that we're intentionally trying to avoid it or it's an oversight. I think we just need to be more aware, maybe consider making this a routine or standard test request with a lot of our cattle FAD investigations with any kind of oral ulcerations or similar symptoms. I don't know what other states are like, but I was just curious when I saw those numbers this morning. I was surprised to see that we hadn't had as many tests as I thought we would have. And actually with that, I just want to recognize the people on this slide for their contributions. We reached out to a lot of different people for research, questions, and help with this project. I can't add anything to this slide, but I meant to put my email address on there if there's any questions. But I am happy to take some questions right now if we have any. Liz?
I don't see any questions in the chat, but let's make sure if you can just put a question in the chat and we can address that now while Brad is still on the line. Great presentation, Brad. Lots of great information.
I have one more thing I might add, Liz, if we've got a second.
Sure.
A lot of you may be familiar with the Farm Bill and NADPREP, our National Animal Disease Preparedness Program, Preparedness and Response Program, NADPREP. Farm Bill passed in 2018 allows for research money to be extended to our out-of-government stakeholders like states, universities, industry, veterinary organizations. Some great projects coming out. Dr. Wallen mentioned two this year. The funding priority topics are focused really on outreach and education to do with disease prevention, detection, response, and preparedness. So similar activities to what we saw or what we were doing in this project. So just a little shout out to encourage, if you have folks or partners out there that might be interested in doing some disease prevention, detection, response types of projects, they can go to that NADPREP website. The applications are due August 6th. So it's just to encourage more projects getting done out there. We've really seen some good stuff coming out in the last year already from the previous proposals. So that's all I've got.
Good advertisement. We do have a question. I may have missed how you choose animals to survey. Were they only symptomatic or were they asymptomatic as well?
Yeah, good question. So other than the two animals that we had done FAD investigations that I included into this, our selection was completely on non-clinical animals. These were cull cattle coming through the livestock market with no, we didn't do examinations or anything. So these were pretty much all asymptomatic cattle. Even we had one animal that we tested at the livestock market that was EHD positive on PCR. We don't know if it was showing any symptoms, but it made it through inspection okay, so we're assuming it was asymptomatic.
So we have a couple comments. It says, great presentation, and your results are amazing. Thank you. Is there a link to the slides? This data is very good to have.
I can provide it somehow. I'm not sure the best way to do that.
Yeah, I can send it out to everyone as a PDF once I get the attendance report.
Sure.
So that's not a problem.
Yeah, and then, you can include my email address in that as well if you want.
I will do that. Yep. And there's another question. Did you examine non-domestic serotypes as well?
No, basically we just, as kind of a convenience, we just tested what was available to us at Kansas State. So we cull cattle and the test that was available to us at Kansas State. So we didn't, but I think there's a lot of opportunities to branch out from this project in the future if we want to. In fact, I think Dr. Keener is working on some funding through his resources to continue doing some testing.
Great. Do we have any other questions? Okay, I don't see any other questions. Let's see. Oh, wait, I have one coming through. Do you have any information about genetically modified midges as a means to control EHD or blue tongue?
I do not. I don't. For our, the resources that I leaned on for our midge activity was the Manhattan, Kansas ARS laboratory. They have, that's where our arbovirus, really our viral vector-driven research is for our ARS is in Manhattan. They're the best resources I have. I don't specifically have any of that information. I would be interested to find out.
Okay. And that seems to be all right now in the chat. Okay. Well, Brad, thank you very much for this presentation.
Sure.
This is very good, and I will send out the information to everyone once I get the list of participants. And as long as you signed in with an email address, I can send it to you. I just want to thank everybody for joining today and hope everyone has a great afternoon.
All right. Thank you.
Thanks.
And that concludes our conference. Thank you for using Event Services. You may now disconnect.